Okay, the next derivative skill that we're going to look at is the chain rule. And the chain rule is going to involve taking the derivative, but then making sure that we've taken the derivative of all of the parts that build the actual function. Okay, so let's start this presentation with just re-looking and revisiting the power rule. So with the power rule, if f of x was equal to x to the 14th power, we know that f prime of x would be equal to 14x to the 13th power. Well, I want you to see how that might change if I had f of x is equal to, let's say, parentheses, x plus 7 to the 14th power. Okay, the way that the chain rule comes into play is that now we don't just have x to the 14th power, we have x plus 7. We proceed the same way to start. We're going to take 14, multiply it down. We're going to keep this base, essentially, x plus 7, the same, and we're going to decrease the power to 13. But what the chain rule says is now you're going to take the derivative of whatever that inside piece is. Well, in this one, the inside piece derivative is just 1, so it's no big deal there to change it up. That would be your answer. Let's try one more. Suppose I gave you f of x is equal to x minus 20 to the negative 3rd power. Then we would know that f prime of x would be equal to negative 3 times x minus 20, but then negative 3 would drop to negative 4, and we would look inside, but the derivative of the inside there is 1, so we would stop. These are the simple ones. These are ones that really are just an extension of our power rule. Now let's look at one where we have to do a little bit more work, and we'll build the chain rule from the simple power rule. So what we're going to do first is, if we're thinking about the derivative here, we're going to say the derivative starts out exactly the same way as that simple case we just looked at. So 10 times 3 would be 30. I'm going to keep 2x minus 7 the same. I'm going to drop 10 to 9, but now I'm going to multiply by whatever the derivative of that inside piece is, and the derivative of 2x minus 7 is 2. And you could leave it just like that. Let's try one more before we move on. What if I gave you f of x is equal to negative 5 times x squared minus 3 to the negative 2nd power. And I said, all right, let's use the chain rule and find the derivative of that. So we would say the derivative, we're going to look at this outside piece again. We're going to say negative 2 times negative 5 is positive 10. We're going to keep the inside function the same on the first pass, so x squared minus 3. We're going to drop negative 2. Remember, we're going to subtract 1, so that's going to be negative 3. But then we're going to turn around and multiply by the derivative of that inside piece. And the derivative of x squared minus 3 is 2x. And one more quick one here. Suppose we have f of x is equal to 4 times 2x minus x cubed, all raised to the 1/3 power. So this one's kind of messy, but what I want you to think about is the fact that we're going to move through it exactly the same way we've looked at the others. So first we're going to say f prime of x. We're going to take our 1/3, swing it down, multiply it by 4. That's going to give us 4/3. We're going to keep the inside exactly the same, 2x minus x cubed. We're going to take 1/3 and subtract 1, which leaves us with negative 2/3. And now we're going to multiply that by the derivative of the inside. And the derivative of the inside is 2 minus 3x squared. So what you might want to do before you go on to the next slide is take a look at the 3 here that we've looked at. This was the first one, and then we had a second one, and then this is the third one that we've just looked at here. And that might help you really as you continue studying and go on to the ones that are going to be a little bit harder next. Okay, so our next function is g of x is equal to 5x times 7 minus x to the negative 2 power. This one's going to be a little bit different than the ones we have already looked at, simply because what you're going to notice now is that you are going to have a first and a second. This is a product rule. So we're going to use our chain rule and our product rule together here to work through this one. So let's go ahead and look at what we have. As we start, let's say g prime of x is equal to, if this is our first and this is our second, let's move through it very methodically using our product rule. So we're going to say the first, 5x, times the derivative of the second, and I'm just going to put some grouping symbols here. Remember, we don't have to simplify anything, so it's really just going to be a matter of taking and rewriting it a little bit. So the first, again, I'm going to underline it, times the derivative of the second, so I'm going to bring down my negative 2, 7 minus x. This then would go to the negative 3, right? Then multiplied again by the derivative of the inside piece, which would be negative 1. So there, essentially, I've got the first times the derivative of the second. And now what we want to do is say plus the second, which is simply 7 minus x to the negative 2, and we want to multiply that by the derivative of the first. So the first times the derivative of the second is here, plus the second times the derivative of the first. Again, notice that I did not simplify, and you just work through this without any complications in trying to simplify any of it. Okay, so now we've got another one that we're going to use chain rule with, but part of what we have to do with this is kind of decode it first of all. One of the things that I might want to do is I might want to certainly consider that top piece as x squared plus 2x raised to the 1/2 power, right? And that's what we would call our top. And then we would call the bottom I think we're in good shape. That's already written as a power. So this problem is going to be long because it involves a lot of steps, but again, you don't have to simplify anything. So let's start. We're going to say h prime of x. I think I'm going to skip a line so I can make sure I fit everything on here. So I know it's the bottom first, so let's do the bottom. That's going to be 3x 3x squared plus 2x to the 4th to the 5th, right? We've got the bottom, and now we're going to work on the derivative of the top. Okay, so let's look at the top and take the derivative of that. So we use our chain rule, 1/2. We're going to keep the inside the same on the first pass, x squared plus 2x. We're going to decrease the power by 1, and then we're going to go back inside and take the derivative of x squared plus 2x, which would be 2x plus 2. Now notice I've made sure that I have my grouping symbols around that, because otherwise it is going to get a little confusing. But what I have so far is the bottom times the derivative of the top. And I'm going to continue by saying minus the top, so I'll write this as x squared plus 2x to the 1/2, there's my top, times the derivative of the bottom. Okay, well, we see chain rule again. We're going to bring down the 5. We're going to multiply that by 3x squared plus 2x to the 4th. We're going to decrease that outside power of 5 to 4, but then we're going to have to turn around and, bear with me, I'm going to have to go down a line on this, and we're going to multiply by the derivative of the inside, which would be 6x plus 8x cubed. So here's the top, and then this piece is the derivative of the bottom, all over the bottom squared. So we could do this. It's a nice easy way to write it. We can say 3x squared plus 2x to the 4th raised to the 5th power squared. That's the bottom squared. So take a look at this one and make sure that you can go through and see all those different pieces. I know it's a little bit messy, and this would probably represent one of the harder examples we would do, but it is a good one to go through and just kind of pick up those skills of quotient rule and chain rule.